Activity guide choosing the appropriate integration technique in engineering context. Daniel Orlando Preciado Blanco, Heider Santiago López Tocanchón, Joan Sebastián Parra Parra, Ingeniería Industrial, Universidad de Exi, Cálculo Integral. Diana Sofía Poeda Ladino, 28 de marzo 2026. Introduction. Hello, today I will explain how to choose the appropriate integration technique in different engineering contexts. In engineering, solving an integral is not only about performing calculations, it is also about understanding the problem, analyzing the mathematical expression, and selecting the best method. Choosing the correct method helps save time, reduce errors, and better understand physical phenomena. For this reason, it is very important to identify the structure of each integral before trying to solve it. Case 1. Heat transfer in a metallic bar. In this case, we have the integral x times a to the power of minus x. This is a product of a polynomial function and an exponential function. This type of expression is very common in engineering applications. The best method to solve this is integration by parts because it is specifically designed for products of functions. Other methods, such as substitution, are not efficient because there is no direct relationship between the functions. This integral can represent heat transfer in a metallic bar, where temperature decreases along the material. If we choose the wrong method, the solution becomes longer and more complicated, increasing the probability of making mistakes. Case 2. Flow white losses in a pipe. In this case, we observe a rational function which means a polynomial divided by another polynomial. The denominator can be factorial, which allows us to apply partial fractions. This is the most appropriate method because it simplifies the integral into smaller and easier expressions. Substitution is not ideal because the numerator is not exactly the derivative of the denominator. This integral can represent fluid flow in a pipe, including energy loss caused by friction. Choosing the wrong method would make the process more complex and harder to understand. Case 3. Circular tank section. In this case, we have the square root of a quadratic expression. This type of integral is strongly related to circular shapes. The best method is trigonometric substitution, which transforms the expression into a simple form using trigonometric identities. Other algebraic methods are not efficient because of the square root. This integral represents the area of a circular section, such as a weather tank. If we use the wrong method, the solution becomes very complicated and difficult to interpret.
Caso número 4. Case for energy invariable flow. Case for energy invariable flow. In this case, we have a product of a variable and square root expression. The structure suggests that substitution in the best method we can define was as course plus 9 which simplifies the integral significant. Integration by farce is not efficient because it would require more step and make the process slower. This integral can represent energy in systems with variable flow of velocity. A wrong method would increase the complexity and the probability of errors.
Case number 5. Oscillatory motion. This integral is a product of trigonometric function. In this type of expression, it is important to carefully observe the relationship between the functions. Since trigonometric functions often have direct derivative relationships that can simplify the process. We can observe that the derivative of sine is cosine, which makes substitution a good option. This is a key observation because identifying this relationship allows us to reduce the complexity of the integral in a more direct way. So recognizing this pattern is very important in engineering, where efficiency and precision are essential. So we define signs of x to simplify the expression. By applying the substitution, the integral becomes easier to manage. Since we transform into a simplified form that avoids working with multiple functions at the same time. So using trigonometric identities will make the process more complicated and less efficient. Alright, theory is helpful in other case. Here take all that unnecessary steps and make the solution longer and harder to understand. This integral represents oscillatory motion such as waves or vibrations. For example, it can describe the movement of mechanical systems like springs, or phenomena such as sound waves and altering electrical signals, which are very common in engineering applications. Choosing the word method will increase difficulty and reduce clarity in the solution. That is why selecting the correct integration technique is essential, not only to solve the problem, but also to better understand the cycle behavior behind the mathematical model. Conclusion. In conclusion, selecting the correct integration technique is essential in engineering. It helps simplify problems, save time, and avoid unnecessary complications. Also, it allows to better understand the relationship between mathematics and real-world application. This connection is very important because engineering is not only about solving equations, but also about interpreting what those solutions mean in practical situations. So by analyzing each integral carefully, we can make better decisions and improve our problem solving skills. This means identifying partners, choosing efficient methods, and avoiding unnecessary steps that can make the process more difficult. In addition, using the correct technique helps reduce errors and increase confidence in the final result. This is especially important in engineering context where accuracy and clarity are fundamental. Finally, mastering these techniques allows to approach complex problems with more confidence and efficiency. And thank you for your attention.